Hemi engine is an internal combustion engine in which the roof of each cylinder's combustion chamber is of hemispherical form. History: hemispherical combustion chambers, which had been used for centuries in mortars and cannons, were introduced on some of the earliest automotive engines, shortly after proving the concept of internal combustion engines themselves. Hemispherical cylinder heads have been used since at least 1901. They were used by the Belgian carmaker Pipe in 1905 and the 1907 Fiat 130 horsepower Grand Prix Racer. The Peugeot Grand Prix car of 1912 and the Alfa Romeo Grand Prix car of 1914 both were four-valve engines also. Daimler and Riley were also using hemispherical combustion chambers. Stuss, beginning in 1912, used four-valve engines, conceptually anticipating modern car engines. Other examples include the BMW double pushrod design, the Peugeot 403, the Toyota T-engine and Miller racing engines, and the Jaguar XK engine. Technology and implementation: a hemispherical head gives an efficient combustion chamber with minimal heat loss to the head, and allows for two large valves. However, a Hemi head allows no more than two valves per cylinder, and these large valves are necessarily heavier than in a multi-valve engine. The intake and exhaust valves lie on opposite sides of the chamber and necessitate a cross-flow head design. Since the combustion chamber is virtually a hemisphere, a flat-topped piston would yield too low a compression ratio unless a very long stroke is used, so to attain desired compression ration the piston crown is domed to protrude into the head at top dead center, resulting in a combustion chamber in the shape of the thick peel of half an orange. Significant challenges in the commercialization of engines utilizing hemispherical chambers revolved around the design of the valve actuation, and how to make it effective, efficient, and reliable at an acceptable cost. This complexity was referenced early in Chrysler's development of their 1950s Hemi engine. The head was referred to in company advertising as the double rocker head. Benefits and drawbacks: although a wedge head design offers simplified valve actuation, it usually does so by placing the valves side by side within the chamber, with parallel stem axis. This can restrict the flow of the intake and exhaust into and out of the chamber by limiting the diameters of valve heads to total no more than the bore of the cylinder in a two-valve per cylinder arrangement. With a hemispherical chamber with splayed valve stem angle, this limitation is increased by the angle, making the total valve diameter size possible to exceed the bore size within an overhead valve configuration. CIOE engine for another method. Also, the splayed valve angle makes the valve seat plane to be tilted, giving a straighter flow path for the intake and exhauster from the port exiting the cylinder head. Engineers have learned that while increasing the valve size with straighter port is beneficial for increasing the maximum power at higher PM, it slows the intake flow speed, not providing the best combustion event for emissions, efficiency, or power in the normal PM range. Domed pistons are commonly used to maintain a mechanical compression ratio, which tend to increase the flame propagation distance, being also detrimental to efficient combustion, unless the number of spark plugs per cylinder is increased. Other drawbacks of the hemispherical chamber include increased production cost and high relative weight. These have pushed the Hemi head out of favor in the modern era. Usage: Chrysler. Perhaps the most widely known proponent of the hemispherical chamber design is the Chrysler Corporation. Chrysler became identified primarily by trademarking the Hemi name and then using it extensively in their advertising campaigns beginning in the 1960s. Chrysler has produced three generations of such engines, the first in the 1950s, the second, developed for NASCAR in 1964 and produced through the early 1970s, and finally the new HEMI in the early 2000s. The original design is pretty much the same except for sensors and fuel injection. Currently, Chrysler produces three variations of the Hemi engine, a 5.7L that makes 370 horsepower and 395 pounds-ft of torque, a 6.4L that makes 485 horsepower and 475 pounds-ft of torque, and a supercharged 6.2L that makes 707 horsepower and 650 pounds-ft of torque. Chrysler also released a Hemi 6 in Australia with a non-full hemispherical chamber but the top-of-the-line 4.3 265 cubic inch motor made 302 horsepower. They came out as 215 120 horsepower, 245 160 horsepower, 265 Sautome and Principe Dobras 203 horsepower, and Chrysler Roots Group also inherited the Humber Super Snipe 3-liter Hemi 6 making 130 horsepower. Ford Ardun heads for the Ford flathead were perhaps the first use of a hemispherical head on a readily available American V8. First offered in 1947 as an aftermarket product, these heads converted the Ford flathead to overhead valves operating in a hemispherical chamber. Zora Arkus Duntov, who later worked for GM and was a major force behind the development of the Chevrolet Corvette, and his brother Ura, were the ARDUN of Ardun. Ford produced an engine with two overhead cams and hemispherical chambers in the mid-1960s. The engine, displacing 425 cubic inches and belonging to the FE family of Ford engines, was known as the 427 SOHC. It was also known as the Camera. It was basically a set of SOHC Hemi heads that bolted onto Ford's FE engine block. The 1964 engine was designed in 90 days of intensive engineering effort for use in racing. The 427 SOHC used the side-oiler engine block modified slightly to deal with the missing in-block cam among other OHC issues. Because of their power levels, and the fact that Chrysler had showed Bill France that a DOHC 426 Hemi was in the works, it was banned from NASCAR races, though allowed in certain drag racing classes. After the NASCAR ban, Ford continued to produce the SOHC, selling it over the counter to racers and others who used it to power many altered wheelbase AFX Mustangs and supercharged top-fuel dragsters. Connie Kalitta, Pete Robinson, and Snake Prudhomme all used the engine in their top-fuel races. In 1967 Connie Kalitta's SOHC-powered Bounty Hunter won top-fuel honors at AHRA, NHRA and NASCAR winter meets, becoming the only Triple Crown winner in drag racing history. Dynamometer results of the day showed the SOHC Hemi producing almost 700 HP in crate form. The overhead cams meant that it was not as PM limited as the Chrysler Hemis were with their pushrods and heavy and complex valve trains. Later Ford engine designs with hemispherical chambers included the Calliope, which used two in-block cams, arranged one over the other, to drive 3 valves per hemispherical chamber. The pushrods activating the valves from the top camshaft were almost horizontal. In 1968, Ford brought out a completely new engine family called the 385 series. This engine's heads used a modified form of the hemispherical chamber called semi-Hemi. In the 1970s, Ford designed and produced a small block engine with hemispherical heads to address the growing concerns about fuel economy. Unfortunately, even with an ahead-of-its-time direct fuel injection system feeding a stratified charge chamber, the Hemi's emissions could not be made clean enough for compliance with regulations. This plus the cost of the valve actuation systems, along with the cost of the high-pressure pump needed to deliver fuel directly into the chamber, as well as the Gilmer belt drive system needed to drive the pump, made further development pointless at the time. Most 1980s four-cylinder Fords used the Ford CVH engine, CVH meaning compound valve, hemispherical. In 2007, taking advantage of the improvements in equipment, computer controls, and chamber design during the intervening years, Ford introduced its non-Hemi EcoBoost line of direct-injected engines. Aston Martin. Aston Martin's famous DOHC V8 used a hemispherical chamber during the late 1960s through the late 1980s. Each cam controlled one set of valves, either a bank of intake valves or a bank of exhaust valves. The Aston Martin V8 5.3L produced 315 HP. Mitsubishi produced several Hemi engines including the Orion, Astron, and Saturn units. Alfa Romeo has produced many successful Hemi head engines throughout the years. Arguably one of their most beloved examples is Giuseppe Busso's original 2.5-liter V6, which has been cited by some as one of the best and most distinctive sounding production engines of all time. Part of this praise is likely because the hemispherical heads on the original two-valve engine allowed for an almost completely straight exhaust port, resulting in a less diluted or muddied engine's sound, allowing Alfa Romeo to use quieter stock exhausts without losing much of their distinct and beloved race-bred engine noise. Porsche has made extensive use of Hemi head engines, including the air-cooled flat-six engine in Porsche 911 models from 1963 to 1999. The 1973 2.7L version generated 56 HP per naturally aspirated liter of piston displacement. Jaguar used this head design, beginning in 1949, on the legendary XK engines, which powered cars ranging from the Le Mans winning D-Type to the XJ6. Lancia. Both the Lancia V4 engine and the Lancia V6 engine used hemispherical chambers. Lotus used hemispherical chambers in some of their engines. The relatively large valves possible in such a chamber allowed large volumes of air-fuel mixture to enter and exit the chamber quickly. Not always completely combusted. In the modern emissions era, the Hemi chamber has begun to fade away from continuing development. The hemispherical combustion chamber is the simplest, and easiest design to understand. As such, it has served for more than a century as the basic design in combustion engines, from which all other improvements and engineering developments derive. As the engineering involved in new engines has improved and evolved, the true hemispherical chamber has morphed and twisted into more sophisticated and complex designs that are meant to extract more power, with lower emissions, from any given combustion event. Design evolution in modern engines. Many of today's engines use active combustion chambers designed to tumble and swirl the fuel-air mix within the chamber for the most efficient combustion event possible. These active chambers usually look like kidney beans or two merged small Hemi areas surrounded by flat quenching areas over the pistons. By the end of the 1970s, development of engines utilizing true hemispherical chambers had ceased in the US, continuing in places like Italy, on Alfa Romeos for example. It had been gradually displaced by newer emissions-friendly engine designs. Today, Hemi is more of a trademark than a description of a combustion chamber. References